Hi, and welcome to the video that covers the lab for 9-9 for 8th grade science. Now, today we're talking about seasons. We're going to talk about how the sun impacts the earth, whether you directly or indirectly at an angle. We're going to talk about the 4 different seasons and then the solstices and the equinoxes. Okay, so let's start off talking about summer solstice, winter solstice. Now, we can split the year up into 4 seasons. The really hot season, which is summer, the really cold season, which is winter, then we have fall and spring, which can be roughly the same temp, but in one it's warming up and the other it's cooling down, right? And in the middle of each of those seasons, we have what's either an equinox or a solstice. Now, if you're having a winter solstice in one hemisphere, let's say the southern hemisphere, you're going to have summer in the opposite hemisphere. Therefore, their solstice would be the summer solstice, and then it would switch depending on the time of year. Now, for the other two, if it's fall, you're going to have a fall equinox. If it's spring, you're going to have a spring equinox. They fall roughly in the middle. Now, the winter one is roughly about the same time as the shortest day of the year, which is, I believe, December 21st. The first thing on the worksheet that we're going to be looking at is solar panels with little Christmas lights attached. And what we're going to be doing is experimenting with direct and indirect light. So the first thing says, what happens to the brightness of the Christmas light when the solar panel is straight on with the lamp? So here I have a lamp pointed against the wall, very bright. My solar panel, a little Christmas light. So I'm going to take my solar panel, I'm going to point it directly there. So what happened to the Christmas light? You'd write that down. Next, it says, what happens to the brightness of the Christmas light when you angle the solar panel like the picture below? So I'm going to start with it straight on like before, and we see how bright it is. Now I'm going to slowly start to angle a little more and more. Now, what is starting to happen to the brightness of that light? As I go back up, back down, what is happening when the light hits it indirectly versus directly? Next, this question says, how does changing the angles of the solar panel and lamp affect the brightness of the Christmas light? We just saw how that works, so all you have to do is describe it. Next, why does the Christmas lights get brighter or darker? So what is happening when we get direct light versus indirect light? Please read this little blurb at the end, and then we'll go on to the next activity. Here we have station 1. The purple cone at the top shows the extension of the axis as it exits the top of the planet, and it is pointed behind me towards the North Star, which we've made the opposite wall in the classroom. Now, we've put an upper and a lower solar panel, and they are A and B respectively. And if we look on our sheet, it says we're going to mark an X for each solar panel. So which is brighter, A or B? So if we look at A, it's about that bright. If we look at B, it's about that bright. So we would put a mark in the corresponding category for which one's brighter. Which one makes the light darker, A or B? Next we have, is the northern hemisphere the top panel or the bottom panel? Is the southern hemisphere the top panel or the bottom panel? And then the summer season, June 21st, right? Is that panel A or panel B? Which one of these two areas is summer based on what we can tell? Is it the brighter light or the dimmer light? Next, we want to know which one would have the winter solstice. Would it be the top or the bottom, the northern hemisphere or the southern hemisphere? This is station 2. At station 2, we're doing the same exact thing we did at station 1, except now we're going to hold the solar panel above A and look at the brightness, and then above B and look at the brightness. Okay. Now, what is the brightness like? We can angle them a little bit so they match more of the roundness, whatnot. But again, we are pointing towards the wall that was behind me at station 1. We're pointing to the same wall. We're imagining we're rotating. So if the upper hemisphere A started in summer, what should it be this time? If it started in winter last time, what should it be? Remember, it's the next following season. Now we're at station 3. This one has a little bit brighter of a lamp on it, so it's a little easier for the solar panels to work. Again, we have our northern hemisphere and our southern hemisphere. So we need to determine, where is summer? Is it the north hemisphere or the southern hemisphere? Which is brighter? The solar panel on the top or the solar panel on the bottom? Which one is lighting up more? Okay, if I walk back, you can see that a little better. Okay. So, again, we just had a season at station 2. It should be the following season. Does that match your expectations based on what the solar panel shows? Please fill out the chart, and we'll go on to station 4. Station 4 is very similar to station 2. Again, you're going to use your own thing to test it, but instead of a light, this time we're going to have sound. So I'll do it for you. Ready? Above A, above B, above A, above B. Which one is the sound louder? Because the sound works much like the lights. So if I put it directly and then slowly angle, okay. So again, we're trying to determine which season each of these are, the north and the south, A and B, northern hemisphere, southern hemisphere, northern hemisphere, southern hemisphere. And you're going to answer the checkbox. Which one do you think would be brighter? Which one do you think would be dimmer? Where is summer? Where is winter? Where is fall? Where is spring? Which seasons are on this one? If we're shown. Again, the top is pointing towards the North Star at the back of the room. All right. So I hope that today's activity lab really helped you understand how the impact of the light, whether it's direct or indirect, whether it's hitting mostly the northern hemisphere or the southern hemisphere, creates the seasons. Now, ideally, if it's getting more sunlight, it should be warmer, because that radiation from the sun, the thermal and the solar, is coming in and getting trapped on the earth and heating it up. Now, the other side should be colder. So if the northern hemisphere is getting more light, the southern hemisphere should be a little colder, and vice versa. If the southern is getting more light than the northern. But what happens when both sides get close to the same, like subjects or like stations 2 and 4? Okay, in that case, that's spring and fall, which have roughly the same temperatures, but one is heating up and one is cooling down, so they kind of meet in the middle. I hope this has helped you understand all that. If you have any other questions, feel free to email me. Try to fill out that worksheet and turn it in. Thank you very much. Bye.